Okay, everyone, thanks for being here. So I'm stepping in for Anna in the last minute. So I apologize that this talk will not be specifically on economics, but I will talk more generally about science and scientists. I'm Hyejin. This is joint work with Jiangnan Liao, our PhD student at UCL and CRIM, who must be here somewhere. So in this paper, we address the issue of age-based career opportunities and gender diversity in academia. So as we know, career progression in academia often hinges on our success early on in our career, especially by a certain age, either academic or biological age. So for example, tenure evaluation in the US, you have to perform well by the 6th or 7th year since hiring. Then you are subject to up or out vote. Take the case of ERC starting grant. You are only eligible if you are within 7 years since PhD. If you are 8 years since PhD, then you are not eligible. So although academic and biological ages are correlated, some institutions use the biological age more explicitly. So in the case of the National Natural Science Foundation of China, which is the NSF counterpart of China, they impose a very strict biological age limit for funding applications. Of course, the problem of using this uniform age limit for application or award or performance evaluation is that it ignores a heterogeneity in people's age productivity profiles. So depending on your research fields or your research methods, your productivity peaks at different ages. For example, taking economics as an example, if you are doing structural estimation of a very complicated IO model, it may take forever to publish one paper. Whereas if you're doing like a lab experiment, you can generate your data, you can publish more quickly. So is it fair that we compare people's performance by the 70 year since PhD? Also, as Petra's, I missed the talk in the morning due to teaching, but in Petra's other paper shows female scientists tend to peak later than male scientists. So if we apply a uniform threshold, then women may lose out. So of course, this age-based career opportunities may contribute to the issue of a leaky pipeline and underrepresentation of women in academia generally. As Erin's paper pointed out, actually, once you miss out on something, you also lose a future success because of massive effect and snowballing effect of early success. So it's so if missing out this opportunity early on may hinder women to climb up the ladder in the future, and then we may lose them in the pipeline. Also, we care about gender representation, not because we only care about women, but also gender representation itself affects research and society. For example, inventors tend to invent things that are useful for people like themselves. So women invent things that are useful for women. And then people from certain demographic groups would invent things that are useful for them. So this has implications for inequality and welfare. And also, from growth papers, we know that utilizing diverse talent pool fosters economic growth. So we do care about representation of women in science. So in this paper, we focus on age-based career opportunities as a potential hindrance to the career progression of a female scientist. To this end, we exploit a new policy at the National Natural Science Foundation of China that suddenly extended the age limit for female scientists eligibility for an important early career grant. Previously, you had to be below age 35 to be eligible. In 2011, they said, oh, women, you can apply as long as you are within 40. Whereas the males' eligibility still required for them to be under 35. So we analyzed the impact of this gender-specific age extension for grant eligibility from the funder's perspective. What happens to the composition of the winners pre and post reform? And then we analyze the impact from the affected cohorts perspective. So individual scientists, what happens to their career? So we speak to two literatures we first relate to studies that analyzed how different funding schemes affect scientists or scientific outputs. And secondly, we speak to the gender gap in academia more broadly, as the audience here have contributed. One paper which is very closely related to us is the paper by Heather Antico and co-authors from 2018. They show that the gender-neutral tenure clock stopping policy did not help women, because the male assistant professors, when they go on leave, they take the time to write more papers. So it kind of because men and women are compared, this hurts female assistant professors. But what we are doing here is interesting, because we look at a policy which is targeting women. So we are not increasing the age limit for both men and women, but only women. And then, and then another aspect is that this age extension was given irrespective of child birth status. So it's possible the Chinese government wanted to promote talented scientists to have more kids. So they have this very low fertility problem, but that's not our focus. But we don't know what the true intention is, but this is not tied to having a child. Okay. So the plan of the talk, I'm going to talk about the institution and data, and I will show you evidence from the funders' perspective, what happens to the composition of winners, and then the cohort analysis, and then further consequences of the reform. So how do I minimize this? Okay, so National Natural Science Foundation of China. This is like a US NSF, but Chinese counterpart. So it is a very important funding source. So here we are tabulating the top 10 funding agencies that are cited, or they are acknowledged in published papers in science and technology. So number one in the recent years is NSFC. This is higher than US NSF, which is number 4, and then higher than UKRI and ERC. It is a very important funding source. And then also, this is a very important funder within China. For Chinese scientists, so this is the number 1 source of funding. And it is by far the most acknowledged funder in China. So given this, we focus on a funding stream called the Young Scientist Grant from NSFC. This is an important early career grant. So talking to Chinese scientists, we find out that winning this is very important for your promotion. It's not only to fund your research, but also winning this sends a signal that you are very qualified. So then this is given, you can win this only once in your life. And the monetary value is not so much, but it is something for the Chinese scientists. But the most benefit is really the signaling. And then, so in 2011, they increased the age limit from 35 to 40 for women only. So why did they do this? So like in other countries, yes. Maternity?
Were there already maternity extensions like
No,
years?
No. So before this reform, they did not have any maternity provision. So everybody had to be below 35. Okay. So they introduced this policy to address the Chinese version of the leaky pipeline issue. So the Chinese government realized that it's a loss from the society's perspective that you keep losing very talented PhDs. So when you look at PhD, there are enough women. Postdocs, fewer. And then assistant professor, fewer and fewer. So why would you waste these resources who have already acquired a lot of human capital? Okay. So to retain more women in the profession, they introduced this policy. And then some survey by Ma and Xu 2022 show that, most 89% of women are married and 77% are married with a child by age 30. So between age 30 and 35, that's a critical stage where things are happening for women. So they may slow down on measured on superficial way. Okay, so. And importantly, this policy was giving extension to eligible age, but there was no quota for women. And there was no quota for female grantees or review committee. So there was no quota policy. It's not affirmative action. It is giving more years to apply for talented women. So we draw on a number of data sources. The first is the National Natural Science Foundation of China. So we collected the data on the universe of grants awarded, including non-young scientist grants. So there's a regular grant that are given to senior regardless of age, and there's a young scientist grant. And we know a lot about the projects, how much they got, and what is the duration, what is the project topic, field, etc. Then, because of a resource constraint, yes. Young scientist grant. It is so we have the success rate maybe 20%. Yeah. So they have this data set covers many fields. So we focus on chemistry. First of all, because we had limited budget for RAs, and we needed a lot of undergraduate RAs to look up the people. So we started with the chemistry, partly because chemistry is a field where China is very, very strong. And secondly, that's a field where there are enough women. So when you have a policy, you want to have women to draw into this scheme. So we thought starting with the chemistry is a good idea. And then, yeah, we have the people who won the grant, and we need to know their publication success and other career outcomes. So we draw on Dimensions AI data. For all the principal investigators and team members on NSFC grants. And then we know for each scientist, whether their funding and publication status over their career. And then the important part is the CV and website. So the NSFC data show the names, but we don't know their gender and we don't know their age. So an army of RAs had to look up their CVs and websites, and we determined their birth year and the gender. Of course, if we had a lot of resources, we could do this for many, many fields. Okay. So first of all, the composition of winners. So what happens to the composition of young scientist grants before and after? So this is what we find. So before the reform, around 33% of awardees were women. The rest were men. After the reform, the female share increases to around 40%. So if you extend this figure to later years, we continue to see it stabilizing around 40%. Okay, so we have more women. What about the composition? So here, the red and blue show the young.
Just a question for the success rate, even at an aggregate level, we don't have stuff by gender or application by gender.
So from the official sources, we know yeah.
Okay, so here it's driven by a change in the success rate or in the number of in the share of application. Do we know that?
This is driven by success rate stays constant over time.
Okay,
more
so
or less.
more
this
women
is
apply.
driven by more application and more success. And then here, so pre-reform, 33% young women, 66% young, 67% young men. And after the reform, we start to see older women winning, right? The green bar shows women who are above 35 who are winning this grant. So they are around just under 10% of the total awardees. So looking at this, you may say, oh, yes, it's obvious, right? We extended the deadline, but it's not. It's not mechanical because they can only win if they're good. Just because you extend the deadline or extend the age limit doesn't mean that there are enough women who can win. So the fact that we do see that 10% of older women are 10% of these are older women means there were older women who were missing out before because of the binding age constraint. Okay? So this result is, to me, very clear evidence that this binding age constraint were kind of missing some women, some talented women. And then this is the share, but of course, in terms of overall quantity, the number of grants are over time increasing, as well as the number of scientists. So there are many more scientists in every cohort, and they also have more more grants. But if you look at the success rate, it is pretty constant over time. Which dress so that's, if you can see, the sample size is quite small, so it's very difficult to slice them further. That's why we do it like but I see your point.
Do you have data also on later years? Because this is in partial equilibrium, but in general equilibrium, you don't want young women to postpone applications, right?
So I will show you a little bit of the intertemporal substitution effect, but we do have data for later years, so I can extend this further.
And do you observe a change in the success of young women?
You will see who is crowded out, whether it's men. Well, we have it a little bit. It's not young women who are crowded out, it's younger men who are crowded out in the first year. So in the future, so that's a good point. We have to check,
You know, you can apply later. Maybe you want to wait because you know that you can only win once, and in the end, in general equilibrium, the effect may be smaller if you look at 5 or 6 years later.
So I will show you a little bit of the short-term effect on the younger cohorts, but that's a good point. We can look at the longer term, but anecdotally, people apparently they don't differ. For them, winning this grant is like having a top 5 publication. So every scientist compete every year. So you can apply as many times as you want until you get it. Then let me just.
Now talk about the gender difference. I'm just wondering, when the committee review the application, are they aware of the gender is anonymous or not, the review process?
Everybody, so whether there's a reform is a common knowledge, but then whether the committee are instructed to be more lenient towards, we are not aware of any of these policies, but we cannot rule out anything that may happen because of this announcement. But we know that there's no specific policy for the committee or the funding criteria. Okay. So then let's look at the quality of the winners. In the post period, we have these older women, right? If you evaluate the people based on their outcomes by the point of winning, there's no difference between young men and then older women. So once you ignore the age, the winners are the same. So from the funders' perspective, they are not losing. Okay? You're not selecting worse quality older women. Suppose the women are slower, then their performance is the same by the time of winning. But let's look at the value added from the grant. So we look at their publications 3 years after winning the grant, 5 years after winning the grant. As you can see here, the green bar is no different from the blue. So their value added is the same. And then also 5 years down the road, they are producing the same. So by doing this policy, the funders are not kind of wasting their money. So they get the same bang for the buck. Okay, so we have shown you the aggregate impact pre-post. Now let's look at the individual scientists who are affected by this policy. So through the cohort analysis. So what we do is the following. So we know that in 2011, some women who were born between 1975 and 1971 were shocked. They previously thought, oh, they are out because they're already above 35. And suddenly they are told that, oh, look, you now have until 40. Then the women who are born in 1971, they have 1 extra year, windfall extension. And the woman who is born in 1975, they are given 5 years extension. So ideally, we would like to see this continuously, but we can't really slice the data further because the sample is very small. So this orange bar, they are treated women. And then let's look at the women who are slightly older, born slightly before, then they're already above 40. So even under the new policy, they are not eligible. So we call them control group. And then we construct the same comparison for male scientists. And then what we do is comparing treated and control women and or treated and treated and control male. We need both of them. The reason is, if you just compare treated cohort of women to control women, you pick up the effect of cohort effect. So in science publications and all these outcomes, you have a very strong cohort effect. So we need an additional difference. So to illustrate that, let me show you the raw data. This is the number of grants that you are holding at a certain age. So the top line, TM, is a treated male who are kind of youngish men, and then control male, treated female, control female. So there's a very strong level difference. Also, the trends are very different. So if you did a naive deep in deep and then do something like this, you still get pre-trends. So this is a treated female minus a control female. But they will not address the cohort effect because every newer cohort, they publish more or they have more opportunities. Okay. Then we need an additional difference. So we look at treated male and control male to take out the cohort effect. So if you take the difference between blue and red, that gives us a triple difference, and we can eliminate the pre-trends. Similarly, you can take a male-female difference among the treated cohorts and take another additional difference between control female, control male, and then take another additional difference, then you can remove the pre-trends. So that in equations corresponds to this type of a triple difference equation. So we will look at a person, scientist I of gender G, cohort K, age A outcome on the triple interaction term, conditioning on gender-specific cohort effect, cohort-specific age effect, and the gender-specific age effect. We estimate the beta that's specific to different ages. So this is what we get. Before 35, there's no effect, but the treated women who got a windfall shock of 1 to 5 years extra time, their chances of winning Young Scientist grant increases by around 15 percentage point by age 42. So previously you were too old to apply, but now you get this chance. So these women win because some of them are truly qualified, but they were just not fast enough to make it by 35. Yeah.
I had a question on how you can tell the difference between people just having more time to refine their application versus the issue of not accounting for the difference in the women's peak performance. Because the extension is just for women. What would it look like if it was also for men? And I also would like you to sort of comment on, I found it quite interesting how you mentioned that it seems that the substitution, the older women are taking the younger men and the younger women are not being as affected. So is it that the older women have higher quality proposals as opposed to younger men, or is there something along those lines?
So we interpret the outcome as is. So whoever wins, whoever wins the grant must be better than who is not winning. This is how we interpret it. So that means if some of the bottom of the younger men are crowded out, they must be worse than the older women who are winning. Between the substitution between younger women and the older women, we don't have a very, very clear-cut answer for now.
If they are affiliated with the top Chinese universities, it is possible they might crowd out the younger men.
So yeah, so
institutions, yeah.
So a good question. We don't have data on applicants, so we cannot say much about it, but I will show you something about affiliations, and then you will see in which direction this goes, where the older women are. Yeah, so we verify the same result using the dimensions data. So dimensions data AI seems to be very good at picking up the grants. And then what about the crowding out or crowding in? So if I'm winning Young Scientist grant, do I now stop applying for other grants, so it crowds out other types of grants, but we find that it's not the case. So if there's the net effect that comes from the gross effect from Young Scientist grant. You don't stop applying for other grants. Then the spillover cohorts, what about what's happening? Yeah.
I thought that you motivated it by sort of age productivity profiles being different between men and women.
Yeah.
So, I mean, just to go back to the earlier question, how do we know that the women for whom this is now extended for have later peaks in their age productivity profile, as opposed to they previously applied, they weren't successful, but they now know more about the submission process?
So
What do we
This-
know about their age productivity profiles that we're essentially setting the threshold too low to begin with?
yeah, so there are two. So if I can show you I'm writing down a model right now, so it will be easier to explain. Suppose that in any group, like if you are at the top 20%, your value added is higher than if you are top 40%. Then if you just, because of the speed of producing things, women are always slower than men, equally qualified men. Then even the top 20% of women may be below the top 40% of men in terms of observed signal now. But it's still these women are top 20%, so their value added potential is greater than the men who is top 40%.
No, I agree.
So-
There also exists modern age productivity profiles the same genders, and extending the limit just allows a different, it's not purely a mechanical effect, but it just allows a greater number of women to be eligible later, and that's why you'd find this effect. So can you distinguish how much of this comes from differences in age productivity profiles across gender? And the reason why these women weren't able to get the grant before the policy is because they peaked too late.
So to answer that, we really need to know the threshold, and yeah, we'll think about that. But I don't have a very good answer at the moment.
You show that even fewer obligations
Than men at the time they win the grant. So isn't that answering a little bit the question that Imran had on the age profile? So I remember that the cumulative publications of women when they win the grant is actually smaller than that of men
For the younger women.
for the younger
Yeah.
women, and
Yeah.
that it increased. So it seems that you give women the time to get more or less the same number of publications that actually men have at the time they win the grant. Is it the case, or?
So this is the publications we were showing is the cumulative publications by the time of winning. But to answer Imran's question more like fully, we really need to trace the profiles, and then we think about the threshold that the committee is imposing, etc. So we don't have a very concise answer for the time being.
I think you should be able to use the distance from the reform, because if the reform is implemented, if I'm 35 and then they tell me now you have one extra year, the decisions that I've taken already determine how productive that extra year is going to be. So there's not going to be any effect of the reform, right? Because you've already given up basically on this.
I see.
But
So
as you go to younger and younger cohorts, then the age profile of women should start looking, the productivity of women should start looking like that of men, because they do not anticipate this running out at 35.
yeah. So actually, so it will be very profitable to look at the cohort-specific responses for the younger women. They have more time to adapt, and yeah, we should do that. Despite we can try to do that despite the sample size issue. Yeah.
So from home, someone asked do you control for having children?
No. This grant, so we don't observe their fertility or family status. So the data, we collected their age and gender from the web, and the grant data only reports their name in institutions and their research field. So also the policy itself is not tied to childbirth status. Okay. So let's moving a little bit to the younger women issue. So we have this control cohort who are super old, who are never eligible, and then treated cohorts who are given a windfall extension of 1 to 5 years. And then what about the next cohort? These are younger women who are who were at the time of a reform announcement, they were under 35. So they already still have time, but now they hear that, oh, I have 5 more years. What should I do? So should I slow down and like defer my application? Well, what do they do? So anecdotally, that's not what's happening. They keep applying until they get it because they have to publish, okay? But still it's interesting what's happening to their chances of winning the grant. So we compare to check the spillover effect. We do the triple difference between control and spillover, like we did for the treated cohort. And there we find that there's a slight dip in the chances of winning the grant between 32 and 35. So it may be voluntary thing, or it may be crowding out from the older women who have more publications. But eventually, what they are not losing. Their chances of winning the grant, the young scientist grant by age 42 is still higher than before. It increased by 11 percentage point. Okay, so they are not hurt by this. And then I want to spend a little bit of time about discussing the unintended consequences of this reform. So it achieved what it wanted, right? But then what's interesting is we also find the increased diversity in other dimensions. So for example, region. So there are more prestigious regions and more remote regions in China. So we rank the 30 regions within China based on how many young scientist grants they used to win before the reform. So there are more regions like Beijing and Shanghai, but there are also less prestigious regions. But because older women tend to be located in less prestigious regions, by increasing chances for them, we also increase the grants given to less prestigious regions. So we diversify the regional representation. And also affiliation. We rank the universities based on how many young scientist grants they used to have before the reform. Given that older women are in less prestigious universities, increasing women share also increases share of the grants going to less represented universities. So this is a kind of an interesting side effect of the reform. And then another aspect is gender in not for the PI, but for other members. So we know, not from this paper, but generally we know that there's a strong gender homophily in teamwork. So if you look at research, science, chemistry research labs, if the PI or the professor is a female, you tend to see more female members. And then also you tend to see more female students. Okay? So this tendency of homophily, gender homophily, did not change because of this policy. But if you increase the female PI share, then you should mechanically see more women in research team. Right? You should see more female members. So that's what we find. These all by giving the grant to older women, we increase the share of female team members who are not PIs. So that's a pipeline. So these are postdocs and other APs. Okay? And then lastly, we also find that the share of female students affiliated with this older female, that they also increase. So giving money grant money to female PIs, not only help them, but we also generate a we retain bigger pool of talented women in the pipeline. So this policy seems to have achieved really amazing things. So to conclude, we evaluated the NSFC reform, extending gender-specific age limit extension, and we find evidence that there were qualified women who just missed out because of the binding age constraint. So relaxing that somehow managed them to help them to win the grant. And this paper raises this is an ongoing project, by the way. So our work raises this question about how we should allocate the grants. How do we reward people? Should we assess people's performance by a certain age? or by the time you're applying. So US NSF grant doesn't care about your career stage. It's only based on the proposal, okay? Whereas the ERC starting grant, ERC consolidated, it's giving you very, very tight like a deadline. But why? What is the difference between 7 year out since PhD or 8 year out? So if you're the eight year out person, you could have been the top person in the starter grant pool, but now you're at the bottom of the pack in the consolidated pool. So this kind of arbitrary cutoff could contribute to the like, I don't know, leakage of talented women, if it's true that women are slower in publishing. Okay. And then, yeah, so there are probably reasons why we adopted a tenure system and age-based allocation of career opportunities, but some fine-tuning of that may be necessary. And also, although this paper was about gender, our argument applies to other things. So what if you have an early career shock? You had to take care of your family member, but this is not reflected in the ERC starting grant. So why you are given extra year if you have a child, but if you have a family sick illness, you don't. So how do you deal with the talented people who have an early career shock? And also, how do you accommodate other underrepresented groups in science? So that's what we have. Thank you.
One question. Did you get also data on the careers of these women? So in order to understand how important was winning the grant in terms of future publications or promotions or other professional outcomes?
So it is yes and no. It is very, if I have a lot of money and a lot of RAs, we can dig up their career. But if you work with the bibliometric data, it's very difficult. We know their publications, their citations, but it's very hard to know their promotions or other things outside. Then you have to look up individually.
And what happens in terms of future publications? Do they publish more in the future thanks to the grant?
Publication, we are looking at publications. So it is so far we do not find a strong evidence on publications, but we haven't looked at, for example, high quality and low quality publications, or whether you are the first author or last author in chemistry. So in chemistry, it's important to be the last author if you are the PI, or if you're the important contributor, you are the first author. So people still publish, but they may not be the important author. So these are the things that we have to look at. It's very, very data intensive process. Yeah.
So Hyejin, I just wanted to use the result on the previous slide to make a connection. I think
This
it's
one?
no, the share of female members, I think was
The members.
yeah, female students, that's the best one.
But this is a bit cleaner. No,
Cool. Okay, let's use this one.
female members, yeah.
So you probably need a model to answer this, but if the problem is that age productivity profiles are differential by gender, makes sense to extend the time. If the difference is more that there's under recognition of women in general, then the alternative policy is to have a quota system, keep 35 because age productivity profiles don't change. 35 is the right cutoff, but you should have a quota for women or disproportionate shares by women. Is it possible to use the model to evaluate that counterfactual? The reason why this result is so striking is that if I'm interpreting this right, that when the policy is introduced, men-led teams hire more female students or more female members in their team. And one interpretation of that is that the policy is people interpreting the policy is saying we want to have more women recognized. And then the question is, well, that's great, but maybe the right way to do that is to have a quota system rather than change the age threshold, because these other two groups, young women and men, are changing the gender composition of their teams. That seems to suggest there's other signals that have been picked up in the policy. Maybe there's a more direct link to the policy to have that effect.
To clarify, this increase in female share may reflect also the intake. So more and more women enter PhD. So you have a more female PhD students or female. So this pre-post is not reflecting just their behavior change. Okay.
Talking.
But yeah, it is an important question. Should we use a quota versus this kind of policy? So we have to. Suppose that the recognition leads to the lack of recognition makes the women look like less productive by age 35. Isn't it still generating? Yes. But the danger of a quota is that you may draw in low quality women, right? So here you still have to compete in the common pool. So you still have to be as good as the other people winning. So that's the kind of the beauty of this policy. Right?
As you're evaluating counterfactuals, one possibility is that the length of time is the same for everybody, but the starting point is different.
Mm-hmm.
So what if people could get to choose when their period starts? So
That's a
you
good
can
one.
apply from,
Yeah.
normally for the men is between whenever they finish their PhD till 35. Women could choose to apply after they have children. So they could choose to have still 10 years between 30 and 40.
So are you suggesting we tell the ERC committee that can we designate the 7 years that we want to apply? Yeah, I think that makes sense.
No, given that
Yeah.
if you want to estimate a model, you could estimate that counterfactual too.
Mm. Yeah.
We have time. Yeah.
So along the same lines, I'm exactly thinking about the same issue, which is what are the kind of underlying structure of the model in terms of the profile of productivity and how they might be different between men and women, especially over time, that would justify having this type of policy rather than other stuff. And that'd be really interesting to kind of have a little bit of a structural model that would do that. And I think, again, I in full agreement. I think quickly what comes to mind is that you only want to have this policy whenever you have essentially a model of what productivity looks like, which is some kind of fixed effect that might vary across gender, and also some time-specific shocks, the distribution of which might also vary across gender. And if you have that, then it might make sense. Now, that being said, what really struck me, but maybe that's an indication of that's exactly what the NSF in China was wanting to do originally, is like when you showed the pre-reform publication at winning, it was lower for women than men. So it looked like they already had a sense that they needed to do some positive discrimination to undo some of the kind of bad productivity representation trade-off that they were having with the previous rules. I find that kind of really interesting.
Yeah. Yeah, so it's intriguing. So I thought that, if they are winning, then they all should have the same mean. But then think about it, among the men, there will be men who will be at the bottom of the publication record. So they should be more comparable if women's distribution is shifted. So the model I have in mind is, okay, it's equal ability between men and women. So if you are at the top 20%, you have the same potential. But by the 50th year or by 35, we have the noise, we have the wrong signal because women have not reached that. We have to give them time to reach their full potential. Then you draw a cutoff and you allocate resources.
Well, yeah, I don't know if the right model is one of kind of overall ability that reveals over time, or just a matter of productivity. What we care about basically is the productivity that you're going to have once I give you the grant, basically. And in that sense, I think the right model is a model where your productivity at any time can depend on a fixed effect and also on a set of unobservable shocks, and that may differ. Because again, in your model, imagine it's just like everybody's growing ability over time. Like you're just revealing more of your ability over time. then yeah, it's always going to make sense to just delay. And you're saying, oh, there is no trade-off in terms of productivity. Yeah, but in some sense, it doesn't tell me whether it makes sense to do that compared to also extending for men. I would get the exact same effect for men. And in that sense, it's not kind of capturing the right trade-off that we're interested in between representation and productivity, I would say.
So when there's a systematic difference in the speed between groups, so it makes sense to give a group-specific extension, but you don't want to give an extension to the very low-quality male, because that's kind of wasteful, right? You also have to draw better people from the next cohort. That's why the tenure and these things exist. Yeah.
Okay. Yeah. So here, I think, a bit on this discussion on what is the shock. Going back to Petra's presentation early today, I think she made it clear that for female scientists that had children, there was a reduction in productivity in their 30s, and that was not the case for female scientists who did not have children. Very similar results, have been shown by the work by Anne-Marie Mason for, using the survey of PhD recipients in the US. So I think it's clear what's the source of the asymmetry, right? That there are clear biological asymmetries between men and women. You can add the social asymmetries, but forgetting about social asymmetries, there's clear biological asymmetries that hit during this time. So I was wondering to what extent you can see that in the data. Could you split the data by women who are mothers and women who are not, when they have children?
So unfortunately not in this data. But then so having a child is a big shock, but even disregarding the child status, it's possible that women study different topics within chemistry that are slower. It's not clear. So plus we know from publication papers that women are they have to perfect the papers more before submitting, etc. So they may be slower in publishing.
But this is not what the evidence says, no? I mean, the evidence by, by Petra this morning says that the difference is entirely driven by women who have children, not by women who don't.
So in this data, it's very difficult to distinguish mothers and non-mothers, but maybe from other sources we could look further into that. Thanks.
Last question.
Yeah, no, it was exactly the same question in terms of the time-specific shocks that might be hitting in the late 20s, mid-30s is childbearing, which would suggest that time is the binding constraint. And allows women to compete on quality in terms of proposals rather than, affirmative action in the form of a quota.
Yeah. So we can think further about quota versus a time extension, but I hope that this gives you some opportunities to think about these policies. Thank you for your comments.